Hello everybody. Here we would like to calculate the minimum velocity at the top of the vertical circular motion. Let us consider a body of mass m revolving in a vertical circle. Let its velocity at the point V is v1. Here we would like to calculate what is the minimum velocity of the v1 required so that we can continue the body in a vertical circular motion. We know being it is a kind of a circular motion, there shall be always a centripetal force. We also know centripetal force is the effective force acting towards the center. Here, being it is a mass attached to a string, that string will always have a tension. The tension is always towards the point of suspension. Therefore, the centripetal force at the top, we can write centripetal force as, the very meaning of the centripetal force is force acting towards the center. If the velocity at the top is v1 square, m v1 square by r is, being this is a body who is having a mass m, its weight always obviously acts in the downward direction. So mv1 square by r is mg as well as the tension. Plus we have to write because both mg and tension are acting towards the center. Of course we can calculate that the tension at the highest point, as T equal to m v1 square by r minus mg, and it is the least possible value, right? This is the minimum tension at any point. But if we look at the equation for the centripetal force, we can see centripetal force is written like m v1 square by r equal to mg and tension. If we want the centripetal force to be minimum, its RHS also has to be minimum. How can we make RHS as minimum? Every body will obviously have some weight, we cannot avoid it. So let us arrange a situation that the string is not having a tension. If the string is having a zero tension, then the velocity will be minimum, then automatically centripetal force is the minimum. That is the situation where the body is going to move with a minimum velocity. Therefore, we have to identify the tension as zero to get a minimum velocity. So, what we can say, for minimum velocity at the top, as anyway centripetal force is provided by the weight, tension can be equated to 0. Then what we can write, m v minimum square by r equal to mg. We can cancel this m and m. Therefore, we can write v minimum square equal to rg. That implies minimum velocity at the top of the vertical circular motion is square root of radius of the string and acceleration due to gravity. If you provide at least this much of the minimum velocity, the body can continue the vertical circular motion at the top. Remember, it can be bigger than this, but it cannot be smaller than this. You might have also noticed that this minimum velocity at this point is not depending on the mass. So, it doesn't make a difference what you are rotating. You can rotate a toy or even you can rotate a train, provided if you give this much of the minimum velocity. So, the minimum velocity at the top of a vertical circular motion is independent of the mass of the body.